In this section, what we'll be doing is we'll be adding and subtracting rational expressions with common denominators. So on Monday, we did multiplication and division, because multiplication and division of fractions is so much easier than adding and subtracting, because in order to add and subtract fractions, what do you need? A common denominator. So that starts to get a little tricky. In this section, they do have the common denominator, so it's not too bad. And we only actually do 3 problems like that, and then the rest of the notes is helping us get prepared for 14.4, where we're adding and subtracting unlike denominators, okay? So I will be referring in this chapter a lot to cookie cake. Does anybody ever eat cookie cake that you get from like Schnucks or something, the round cookie cake? I refer to that versus pizza, okay? So we're going to be cutting slices. In order to combine cookie cake slices, we want them to be the same size and so forth. But here, what we're going to do is we're going to notice that when you have the same denominator, do you guys see that 2n and 2n matches? You can just actually add a this. So like, say you had 1/5 plus 1/5. What would you have? 2/5, okay? So the denominator that they share stays the same, so that will be 2n, and you only have to write it once. You don't make it 4n, you don't make it 4n squared. Just think you have 2n slices of cookie cakes, right? And then you just do the math with the numerator, 5m plus n. After you combine them like that, you ask yourself, is there any more you can combine? And you can. 5n and m are like terms. So how many total n's do you have up top? 2. You have 2 terms, but you have 5 in one and 1 in the other. So how many total ones do you have? 6 n's, right? So this is 6m over 2n. Is that okay so far? So the denominator that they share stays the same. You do the math on top. A 5m plus another m is 6 m's altogether. And then at this point, you just have to be careful and ask yourself, does anything reduce? The m and n won't cancel, but what about the 6 and 2? And do you guys see why that's okay? Because they're shoved right next to each other. There's not a plus sign there, okay? So we can reduce this to a 3. He just goes to a 1. So your final answer is 3m over n. Is that okay? So first ask yourself, do they have the same denominator? They do, so then just do the math up top. So we're going to do the same thing over here. Notice they have the same denominator. 2y minus 7. So 2y minus 7 is going to be my denominator. Once you realize they have the same denominator, then put the numerators together doing what the math is. So what's our numerator going to be? 2y minus 7. You guys see that? So we stole the first one, 2y, and then we subtracted 7. What does 2y minus 7 over 2y minus 7 cancel or simplify to? Just 1, right? They're just each other. So this answer is 1. All right, guys. This third one has a decent amount of work. Okay, so kind of write small because we're going to have stuff going on. So again, notice that they have the same denominator. So this will all be over x minus 1. The first numerator never changes, okay? So the first numerator is 3x squared plus 2x. What we have to be careful of is this, we're subtracting all of this, and so the negative has to go to the 10x, but the negative also has to go to the negative 5. So it'll be negative 10x, and then what will be the sign in front of the 5 if we have minus a negative? Plus 5. So that's kind of, I'm going to put a star there. That's probably like the #1 mistake that happens, guys, is that when we subtract, it's called a binomial, you need to make sure you distribute the negative to both parts, okay? At that point, we're going to gather like terms on top. So we'll have 3x squared minus 8x plus 5 all over x minus 1. So 3x squared had nothing to go with him. A 2x minus the 10x gives the negative 8x. I'm going to cough again. And then we have plus 5. So, the last thing we have to ask ourselves, does this potentially reduce? Well, in order for it to reduce, guys, we can't just start going and crossing out single terms like the x with the x. We have to factor, okay? So I know there's not a whole lot of room here, but just on your worksheet, feel free to use a scratch piece of paper or whatever. But we're going to do the AC method. And again, I'm going to kind of wave my wand. What are factors of 15 that add up to negative 8? Negative 5, negative 3. And you would factor by grouping, and you would get a factored term of 3x minus 5 times x minus 1 all over x minus 1. Okay? So we use the AC method there. I just did it quickly. And again, that's kind of going to be how Chapter 14 goes. We have to focus on the new stuff, so we can't spend the lecture going over the old stuff, if that makes sense. But I trust that you guys could do that if you had enough time to go do it on your own, okay? So what's the final thing that you notice about that rational expression? The x minus 1s will cancel, right? And since that 3x minus 5 is left on top, that is just our answer, 3x minus 5. All right? So again, we just used our AC method there, but I trust, like I said, if you had your own time, you'd get there. All right, that is all the problems we give for adding and subtracting common things, because I think you see what happens. Keep the denominator the same, combine like terms on top if you can, and reduce if you can. So we don't have a whole lot of practice with that. What they do is, in the rest of the section, they say, you know what, life would be all rainbows and kitty cats and gumdrops if all of our fractions had that same denominator, but they don't. And so what do? We have to get a common denominator. So that's what the second half of the, actually like the 2/3, bottom 2/3 of the notes is, how do we start getting the common denominator, okay? So number 1, factor each denominator completely. And then number 2, your least common denominator, your LCD, is going to be the product of all unique factors found in step 1. Each raised to a power equal to the greatest number. Oh gosh, there's lots going on here. Basically what you're going to do is you're going to factor each of your denominators and realize that whole denominator has to be represented. But if one denominator shares a factor with another denominator, you don't need to write it twice. So think about like 4 and 6, for example. Like what if we had 1/4 and 1/6? What's the LCD there between 4 and 6? It's not 24, right? Like we don't do 4 times 6 and get 24. We say, okay, he has a 2 and a 2, he has a 2 and a 3. So our LCD would be 2 times 2 times 3. Because he needs a 2 and a 2, got it. He needs a 2 and a 3, got it. So your LCD ends up being 12, okay? So that's what we're going to do here. So how I do it is I just focus on the first denominator, 8. Say you did your factor tree, kind of just do a factor tree in your head, what 2 branches would come off to make 8? 2 and 4, but then 4 would become 2 and 2. So 8 ends up being 2 times 2 times 2. Does everybody agree with that? And then 22 is the same idea. What are the only 2 things that 22 can split up as? 2 and 11. 2 and 11. All right? So at this point, when we want to make our LCD, I start with the first numerator, 8. 8 needs what? 3 2s. Okay? I need all of 8 represented, so I need all of those 2s there. Then you go on to the second denominator and you say, what does he need? He needs a 2 and 11. But can't he share one of those 2s? Yes. So what's the only thing he's missing? An 11. All right? So then you just multiply what remains. 2 times 2 is 4. 4 times 2 is 8. 8 times 11 is 88. So the LCD, the smallest number that both 8 and 22 go into, is 88. All right? Let's do it with this guy over here, 5x. What's
88 would be the answer.
Yeah, 88 is your answer. So if we were, and that's what's kind of weird about this section, we don't actually add them yet, okay? But if we were going to add them, we would have to cut in the cookie cakes into 88 slices, right? And then we could combine them that way because they all would be the same size. And we'll do that on Monday, okay? On this one, we're going to do the same thing. 5x splits up as 5 times x. 15x squared splits up as, well, how does 15 split up?
5 and 3.
Yep, so 3 times 5. And then how does x squared split up? X and x, right? So what's our LCD going to be? Well, our LCD needs every denominator completely. So I just start with the first one. What does the first one need? A 5 and an x. There he is. What did our second denominator need? He needed a 3. Do we have a 3 yet in our LCD? No. So we're going to add him. He needs a 5, but can't he share this 5? Yes. He needs an x, but can't he share that x? Yes, but he needs a second x. So the whole idea, guys, is when you build your LCD, you should be able to see both denominators in it. So do you guys see 5x in that denominator? Yeah, those first two. Do you see 15x squared? Yeah, because 5 times 3 is 15, and x times x is x squared. So 15x squared ends up being our LCD. And sometimes that will happen, guys, right? Like if you're adding a fourth of a cookie cake and an eighth of a cookie cake, 8 would be your common denominator, all right? So sometimes that happens. All right, this one, guys, x plus 2, how does he factor? We're going to factor him like this, x plus 2, okay? That's our first denominator. X minus 2, how does he factor? X minus 2. So when we go to do our LCD, we need our entire first denominator. So we need x plus 2. Then you go to do your second one, what do you need? X minus 2. That's different. It's not the same, right? Because if x was 5, one would be 7, one would be 3, right? So they're different. So the LCD actually has both of them. So the LCD ends up being just the product of the two. So sometimes your denominators don't share any factors, and so you just have one denominator times another denominator, and that's your LCD.
So you don't ever want them to cancel out?
Yeah.
Okay.
Well, you might. You'll see what, like where they compare or they share. We'll see some down here in a second, okay? So here, they shared a 2, so we only had to write 3 2s. We didn't have to write 4 2s, right? Here they shared the 3, 5, and x, so we only had to write 3, 5, and x once, and then he just needed an extra x. And then here, x plus 2 and x minus 2 had nothing in common, so we needed both of them, and we multiplied. All right, this one's kind of the same idea. How does x factor? X. How does x plus 4 factor? X plus 4. And the reason why I'm putting it in parentheses is so you get the idea that that's not x. Like you can't share that x. So, what's our LCD going to be, guys? It's going to be our first denominator, x, times our second denominator, x plus 4. You guys agree that that x is not the same as the x that's in x plus 4? Because if x was 5, one denominator is 5, the other one's 9. So our LCD will be the product. If they don't share anything, your LCD is just the product of the two together. All right. Here's where it starts getting like, these are my favorite. I don't know, I'm weird. I like AC method and factoring, stuff like that. These are my favorite where you can kind of just see them sharing those common factors, all right? So 3n plus 15. How would we factor 3n plus 15? What's the first rule in factoring? Look for what? A GCF, right? What can we take out of 3n plus 15? What do they both share?
3.
A 3, okay? So we'll factor him over here. When you take that 3 out, what's that going to leave you with? n plus 5. Is everyone okay with that? So the 3 came out, it took away that 3, and then 15 divided by 3 gives us 5. All right, n plus 5 squared. You guys saw this a couple times on Monday in your notes or on the worksheet you're working on today. How can we show n plus 5 squared in factored form? n plus 5 times n plus 5. So that will just be n plus 5 times n plus 5. All right. So we took the first denominator, took out a 3, so we're left with 3 times n plus 5. We took out the second denominator and kind of just split it up, n plus 5 times n plus 5. So our LCD, guys, is going to be our first denominator completely. So 3 and an n plus 5. But what do we need to add on to that so we represent the second denominator completely? An n plus 5, right? He needed both, and we only have one listed right now. So here is our LCD. And on Monday, we'll talk about what we do with these LCDs, okay? But basically what it is we're going to have these expressions, and they're now going to be over this. So if we change the bottom, we're going to have to change the top. All right, last one, like I said, I like the AC method ones the best. I don't know why. I'm weird. That's why I teach math, right? X squared minus x minus 6 equals what? When it comes to factoring these trinomials, guys, I would be you, and I'd have like a piece of paper off to the side, right? So we would need to think of factors of -6 that add up to -1. and your answers would be -3 and +2. So that's how you'd rewrite the middle. So you'd write x squared minus 3x plus 2x minus 6, and you would do factor by grouping. Just to save us time, I'll write the factored form over here. It's x minus 3, x plus 2. X minus 3 times x plus 2. The same thing would go for that second trinomial. X squared plus 3x plus 2. Factors of 2 that add up to 3 would be 2 and 1. Okay? So we rewrite in the middle, x squared plus 2x plus 1x plus 2, do factor by grouping. That ends up being x plus 2 times x plus 1. All right, so what's our LCD going to be? Well, when it comes to LCD, it doesn't really matter what order you write them in, but I always just start with the first numerator completely, or denominator completely. So the first denominator means what? X minus 3 and an x plus 2. So there's the first denominator, but what do we need to add on so that the second denominator is represented? X plus 1, right? So see how they are like kind of that x plus 2 is the middleman. He can go with either one, right? So here, this way, you can see our first denominator, x minus 3x plus 2, right? But then here, this way, you can see our second denominator, right? So our LCD will be the product of all three. Is that okay so far? All right. And typically, guys, when it comes to this section, you do really well. You factor them and you find that common denominator. So what's the last little section here? Out, not down. Okay. Is what we have to realize is we're going to start changing all these rational expressions to new fractions with new denominators. But if we change the denominator, we have to make sure we change those top. What do I mean by that? I love my cookie cake. So say I'm supposed to get half of my cookie cake. But then someone comes in and just starts cutting it up to 8 slices. I shouldn't get 1 out of 8 slices. I should get 4 out of 8 slices, right? So if we're going to change how many slices are on the bottom, we have to change how many slices are on top, okay? How you do it is you just ask yourself, what if you multiply the bottom by to get to the new denominator? Because whatever you multiply that bottom by, you just make sure you multiply the top by that. So the question is, how did I go from 9a to 27a squared b? Well, let's focus on the number. 9 times what gets you to 27? 3. So we multiplied the bottom by 3, which makes sure, we got to make sure we multiply the top by 3. We don't want to change what we're doing. And I'll show you kind of how we do it. So we have 4b over 9a, right? So we got to figure out, what did we multiply to get to 27a squared b? Because whatever we multiply the bottom by, we're just going to make sure we multiply the top by that. All right? So we said 3 for sure. So we'll write a 3 on top and bottom. What did we multiply a by to get to a squared? Another a. So if we do that on the bottom, we have to do it on the top. And then how did we get to b? We multiplied by b. So do you guys agree that the bottoms line up? 9 times 3 is 27. A times a is a squared. And then b is b, so we'll have it b. So what are we technically multiplying by? We're technically multiplying by 1. So we're not changing our fraction at all. We're just making it look new. So what does my math lab want you to put? They want you to put the new numerator, okay? So what's our new numerator going to be? Well, what's 4 times 3? 12. ab squared, does that look right? You see what we did there? So 4 times 3 was 12. We added an a, and then we added a second b. So that's where b squared came from, okay? So this is going to be the same idea. We have 2x plus 5 and 7x multiplied by something gives us 6x plus 15. And sometimes it's not as obvious as that one we just did. So I always say, if you can, factor as much as possible. 2x plus 5 doesn't factor, but what can you factor out of 6x plus 15? You can factor out a 3, which will leave you with a 2, right? So a 3, if you factor out a 3, You guys see what that is over there under 6x plus 15? 6x plus 15 is just really 3 times 2x plus 5, right? So what's the only new factor between this denominator and this denominator? The 3 is the new guy, right? We already have the 2x plus 5, so when we multiply the bottom by, just the 3. But if we multiply the bottom by 3, we've got to multiply the top by 3. So what's our new numerator going to be? 21x. Is that okay with everyone? All right, last one, and I think we can kind of skip this little step here if you want. Notice the new denominator is completely factored, but he's not. How can we factor x squared minus 4?
X minus 4.
No, what's the square root of 4? You're right there, though.
2.
You got it. X minus 2, you knew what you were doing there. You knew what you were doing, okay? So guys, when you go from this denominator to this denominator, who's the new guy in town? X minus 4. Notice the only thing new that we added was x minus 4. So that means we took this denominator, x minus 2, x plus 2, and times it by x minus 4. So guess what we have to do to the numerator? Times it by x minus 4. He's the new guy. So your answer would be 5 times x minus 4, and what's nice, they don't even want you to distribute, okay? They want you to leave it 5 times x minus 4, which is nice, because sometimes if you go that extra step,
Sadie, the 5.
it was the original numerator.
Okay.
Yep, so and if you need to see it this way, you can. So this is 5 over x plus 2 times x minus 2, kind of do what we were doing, right? Equals this new denominator, x plus 2, x minus 2, x plus 4, minus 4, oh my god, I have like no room. Okay, so who was the new guy? X minus 4, but if we did that on the bottom, we have to make sure we do it on the top.
Okay.
Right?
Yeah.
And then you just multiply straight across, 5 times x minus 4. Okay.